Adding rational expressions. So previously we've talked about how rational expressions are just fractions with polynomials in them. So the rules that dictate how we add, subtract, multiply fractions are the same for rational expressions. And to add two fractions together, and that includes rational expressions, we have to have common denominators. So we're going to do a quick review of common denominators with a simple fraction problem, and then we'll go into our rational expressions. So looking at this one, we have 7 over 10 plus 8 over 15, and we want to add those two numbers together, those two fractions together, but we can't because the denominators are different. So to make them the same, we want to find the lowest common multiple, or sometimes called the LCM, of 10 and 15. So what's the lowest common multiple of 10 and 15? There's a few ways to do it. One is just to make a list of multiples of each. So 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40. So those are the multiples of 10. And for 15, 15 times 2 is 30, and then 45, and so on. But pretty early on, we can see that the lowest common multiple of 10 and 15 is 30. So to add these two fractions, we're going to turn them each into fractions of 30. So I'm going to multiply the top and bottom of the first fraction by 3. So that would make the denominator 30. And I'm going to multiply the top and bottom of the second fraction by 2, because that would make the denominator 30. So 7 times 3 is 21, and then I have over 30. And plus 8 times 2 is 16 over 30. And that's our standard method for adding fractions. So once our common denominators are the same, basically you have 21 over 30 and 16 over 30. When you add the fractions, the denominator remains the same, so the final answer is going to be 30. And then we add the two numerators, 21 and 16. And so we get 37 over 30. And that would be our answer there. Now let's apply that same process to a rational fraction, or to a rational expression. So now we're going to look at an example where we add and simplify a rational or two rational expressions. And so just like with the fraction problem we saw earlier, we have to start by looking at the denominators. And in this case, we actually see that the denominators are already common. So it's nice because we don't have to find that lowest common multiple. So to add two fractions that have the same denominator, you just have to add the numerator, and the denominator is that common denominator. So adding the fraction, or adding the numerator, I'm going to write it in order from biggest to smallest powers. So x squared plus 11x plus 28. So I could leave my answer there, but there's a chance that it's not actually totally simplified as well as it could be. So to do that, I'm going to factor the numerator. X squared plus 11x plus 28. So this is a simple trinomial. Factors of 28 would be 7 and 4 is a good place to start, and those will add to 11. So I can factor this expression into x plus 7 times x plus 4 on the top, and we still have x plus 4 on the bottom. And then we can see that there's a canceling that happens. The x plus 4's cancel, and so my actual simplified expression is just x plus 7. So adding those two rational expressions simplified into something quite nice. So now we're going to look at an example where we add two rational expressions, only the denominators are not common. So we have to make common denominators. Basically, when we look at a problem like this, we want to ask, what would we have to multiply each denominator by as simply as possible so that we have common denominators? And a lot of the times, as in this case, the answer is going to be, well, we have to multiply it by the other denominator. So for example, with that first fraction, which is over x minus 3, and that second fraction, which is over x minus 2, what do we need to do to make them the same? Well, I'd have to get x minus 2 on the bottom of the first denominator and x minus 3 on the bottom of the second. So in this problem, I'm going to multiply the top of the first fraction by x minus 2, the bottom of the second or of the first fraction also by x minus 2. You have to multiply top and bottom by the same thing. Now in the second fraction, multiply by x minus 3 on top and bottom. So this looks like 3 times x minus 2 over x minus 3 times x minus 2 plus 2 times x minus 3 over x minus 2 times x minus 3. And now I've got my two fractions or rational expressions with common denominators. So I can go ahead and add them. So there's my denominator. And on the top, I need to simplify this as much as possible. And so to do that, I'm actually going to multiply each of these numerators out. So 3 times x minus 2 is 3x minus 6 plus 2x minus 6. And then I'm going to combine everything in the numerator. So 3x plus 2x is 5x, minus 6 is minus 12. So I have 5x minus 12, and then my denominator. And when I look at this, there's no factoring I can do for that polynomial on the top. My bottom's already factored, so there's no additional simplifying to be done. And so that is my simplified rational expressions after they've been added together. So one more example for this video. To add these two rational expressions together, we have to start by finding a common denominator. Now, how are we going to do that? It's really hard to see what the common denominator is going to look like, but the first thing we should always do is factor. In our last one, we just multiplied by, multiplied the first fraction by the denominator of the second, multiplied the second by the denominator of the first, and it all worked out that way. But we don't want to do that in this case because we have these big, giant polynomials, and multiplying them would be a lot of work and more than we actually need. So the first step is just to factor each denominator. So in this case, we have x minus 3 and x plus 1 on that denominator, and factoring the second, 3x over looks like x plus 1 and x plus 3. So once we have our denominators factored, we can look at our two fractions or two rational expressions and decide what are they missing in order for them to be common, to have common denominators. What are those denominators missing? And we see they actually have part already present in each. Each of them have a factor of x plus 1 in the denominator. So part of the denominators are already common. What's missing is that the first fraction has x minus 3, but it doesn't have x plus 3. So what I'm going to do is I'm just going to multiply by x plus 3 on the top and x plus 3 on the bottom. And in the second fraction, in order to make those denominators common, I'll have to multiply by x minus 3 on the bottom and x minus 3 on the top. So that looks like 8 times x plus 3 over, and then I have my three brackets in the denominator. But I'm going to go ahead, now that I know my denominators are common, I'm just going to write them for the two numerators. And I have plus 3x times x minus 3. So I've done the hard work. Now I have to simplify. I've given them the common denominator. Now I have to combine 3 times 8 is 24 plus 3x squared minus 9x. I have to simplify the numerator, and I have that denominator. What I often do in the intermediate steps is I don't rewrite the 3 brackets just because it's not worth my time. So I'm just sort of skipping over that so that I can simplify this as quick as possible. And minus, so 8x minus 9x is minus 1x, so minus x plus 24. Can this numerator be factored? Well, I would need to find two numbers that multiplied to 3 times 24 is 72. I just did that in my calculator. So numbers that multiply to 72 and add to -1. But I think I can actually do that. No, not if they have to multiply to positive 72. I don't think I can. No, that fraction is unfactorable. So if the numerator is unfactorable, then I've simplified as much as possible. So I'll write out my denominator, because there's no more steps left. And you can leave that in factored form. And so there is my combined rational expressions.